Hey everyone, and welcome! Today, we're going to go on a little journey to solve some mysteries about something we see every single day, water. We're going to figure out how it can be a hard solid, a flowing liquid, and even a gas you can't see. You ready? Let's dive right in. Okay, so let's kick things off with a big one. You've got a glass of water with ice cubes clinking around in it. Have you ever really stopped to think about that? Is that solid chunk of ice actually the same exact stuff as the water it's floating in?
It's a pretty good question. I mean, on one side, you can pick up an ice cube. It's hard, it's solid. But water, it just slips right through your fingers. They feel completely different. But then again, you know that if you leave that ice cube out, it melts right back into water. So, what's the deal? Let's investigate.
All right, our first puzzle is something you have definitely seen before. We're calling it the case of the vanishing water.
So, picture this. It just finished raining. You look outside, and there are puddles all over the street and the sidewalk. But you come back a few hours later when the sun's out, and they're gone. Or at least they're a lot smaller. So, where did it all go? The first thing you might think is, well, it just soaked into the ground. And yeah, that makes a lot of sense, for sure. But is that really the whole story? Well, we can actually test that idea. Check this out. If you spill a little water on a solid steel plate and just wait a bit, that water disappears too. And we know for a fact it can't be soaking through solid metal, right? So something else has to be going on here. And that something else has a pretty cool name: evaporation. What happened is the liquid water basically turned into an invisible gas called water vapor and just, poof, floated away into the air. So mystery number one, solved. And once you know what evaporation is, you start seeing it everywhere. It's the reason your wet laundry gets dry when you hang it outside. It's how a wet floor eventually dries up after mopping. It's even why you cool down when you sweat. That sweat is evaporating off your skin. Okay, time for mystery number two. And you'll see how this one actually connects to our last one. Let's solve the secret of the sweating glass. Come on, you know exactly what this is. It's a hot day, you pour a super cold drink, and a few minutes later, the outside of the glass is covered in little drops of water. It really looks like the glass is sweating. But think about it. Where is that water actually coming from?
A pretty good first guess might be that the water is somehow leaking or seeping right through the walls of the glass. Seems possible, right?
But here's the thing. If you look closely, the amount of water inside the glass hasn't changed at all. The level is exactly the same. So the water can't be coming from inside. See? Another great example of just using our eyes to test an idea. So if it's not coming from inside the glass, where else could it be from? Well, the answer is literally all around you. It's that invisible water vapor we were just talking about, the stuff from the vanished puddles, that's just floating in the air. This whole process is called condensation. And really, it's just evaporation in reverse. When that invisible water vapor in the warm air touches the chilly surface of your glass, it gets cold and turns right back into liquid water droplets. So cool. So, we've cracked two pretty big mysteries now. And by doing that, we've actually uncovered the big secret behind water's different identities. And here it is, the big reveal. Ice, water, and water vapor are not different things. They are all the exact same substance, water, just wearing different outfits. Scientists call these outfits states: the solid state, the liquid state, and the gas state. This little chart here breaks it down really nicely. You've got ice, the solid. It keeps its own shape, and it definitely doesn't flow. Then there's liquid water. It'll take the shape of any container you put it in, and it flows all over the place. And finally, water vapor, the gas. It doesn't have a shape at all. It just spreads out and fills up any space it's in. So how do you get water to change its outfit? It's actually super simple. It's all about heat. When you add heat, you add energy. That energy causes solid ice to melt into liquid and liquid water to evaporate into gas. And if you take heat away, you remove energy. That causes gas to condense back into liquid and liquid water to freeze back into solid ice. That's it. Now that we get how these changes work, we can zoom out, way out, and see how they all work together in one of the most important systems on our entire planet.
Check this out. This is the big picture. That evaporation we saw with the puddle and the condensation on the glass, those aren't just little science tricks. They are the actual engines that power Earth's Great Water Cycle, a giant system that is constantly moving all the water all over the globe.
Let's just follow the journey for a second. First, the sun shines down, and its heat evaporates water from oceans, rivers, you name it. That water vapor rises up into the sky. Up there, it's colder, so the vapor condenses into trillions of tiny little water droplets, and those droplets form clouds. Eventually, the droplets stick together and get too heavy, and they fall back to Earth as rain or snow.
And what happens to that rain and snow? Well, it fills up our lakes and rivers, and most of it flows right back to the ocean. And then the sun shines, and the whole amazing journey just starts all over again. It's a loop that just goes on and on forever.
So here's a final thought to leave you with. Our planet never really gets any new water. The water we have now is the same water that's been here for billions of years, just going through that cycle over and over again. That means the water in your glass could have been rained on by T-Rex. Seriously. So now that you know how it all works, what part of water's incredible ancient journey do you think is the most amazing?